On October 3, 2025, as NASA's Perseverance rover methodically records a sequence of 20 images from the Martian atmosphere, the sole trace of 3I/Atlas, an authenticated interstellar traveler, appears as a subtle, unclear blot precisely in its anticipated position. However, right when global curiosity peaks and calls mount for sharp orbital photos, around 15,000 NASA personnel get abruptly sidelined, and all formal channels go quiet. This convergence feels like an ideal crisis. Extraordinary irregularities, outlandish ideas surrounding a tube-shaped entity, and a communications blackout exactly as the newest visuals uncover oddities in 3I/Atlas. So what's getting concealed? And why do fresh assertions keep conflicting with established knowledge on extraterrestrial bodies? The tale kicks off from one hazy online post, but spirals into an unforeseen saga. Mere hours after the Perseverance sequence hits the web, a lone image, little more than a vague streak, ignites an online frenzy. Hobbyists in astronomy dive into unprocessed files, superimposing the forecasted path of 3I/Atlas onto the red planet's backdrop. The positioning felt eerily precise. That blot aligned spot on with the CNOS group's projections. Still, the photo's vagueness sparked endless fascination. Over on X, people circled the stretched-out shape with bold crimson loops, dubbing it a tube or stogie, and pushing followers to zoom in on the dots. By the next day, the buzz had evolved. Suddenly, it transformed into a Martian pillar, an alien vessel, or even a stellar data stick. The initial 20-frame assembly got picked apart and shared anew under all sorts of enhancements. Certain discussions swore they detected etchings on it. Some highlighted a shiny, metal-like glow, while others outlined alleged silhouettes, constructing arguments for engineered forms. Backyard investigators started cross-referencing the Perseverance files against past comet shots, contending that no typical comet displayed such a crisp linearity. Every fresh share piled on more guesses, until the tube story overwhelmed rational takes on radiation strikes or visual glitches. Alignment graphics spread through Discord groups for science buffs, where folks meticulously synced the dim trail's direction to 3I/Atlas's expected trajectory. The fit convinced a few, yet for many, the scarcity of crisp orbital shots posed the true puzzle. How come? They wondered. The lone proof stems from a ground crawler amid a swarm of overhead satellites boasting advanced lenses. As the trend picked up steam, it pulled in broader crowds. Fans of space, doubters, and plot enthusiasts converged. The void of sanctioned visuals just stoked the flames higher. Every lingering query prompted yet another shareable update, erasing lines between sincere probing and internet drama. Amid the quiet, rumors bloomed, and the push for clarity amplified with each share. Back in August, prior to 3I/Atlas turning into a hot search, Bertie Dworsky and her Distant Perception group gathered around a locked packet and location points. Their recorded notes, dated and shared well before the Perseverance shots, outlined something remarkably detailed. A gadget no bigger than a USB drive, lodged inside a vast frozen chunk. Per the records, this item wasn't passive. It throbbed, emitting steady targeted signals. The theme of a tech heart buried in a comet-style exterior repeated over various sight-unseen trials, all done blind to the subject's details. What jumps out isn't merely the gadget's size or the throbbing pattern, but the wording chosen. Participants noted veiling, as though the thing's real essence was intentionally obscured, and mentioned outer scribbles or carvings, elements that would resurface in web talks on crafted shapes and signs in the Perseverance series. The parallels are compelling, though timing is key. Such patterns show up in August entries, well ahead of initial leaks about a Mars pass or the exploding tube fad. That said, Distant Perception lacks scientific validation. Its assertions, however vivid or foresightful, can't replace hands-on observations or vetted research. Come October 1st, NASA slipped into a limited closure. About 15,000 workers, technicians, info processors, and outreach experts were formally paused, with just a minimal team sustaining the International Space Station and Artemis operations. For the Mars front, this created an abrupt jam. Observation efforts for 3I/Atlas rolled on as planned, but the group's handling refinement, adjustment, and distribution were mostly unavailable. Unrefined signals kept flowing from satellites and landers. Without the standard flow, public access stayed partial and unchecked, building a pileup of raw info per loop. The Farspace Array maintained its routine contacts, forwarding new info bursts from Embro, Mars Express, and TGO. But every transmission landed amid subdued reactions. Labs in Pasadena and Darmstadt ran with barebones crews. With the majority of staff unable to access their networks, automated routines preserved the information, yet a hands-on examination highlighted numerous issues. These included alignment mistakes, issues from data compression, and potential impacts from cosmic rays, all of which required the complete staff to resolve. The European Space Agency verified that their Mars Express and Trace Gas Orbiter operations had gone smoothly, but they delayed any public announcements, emphasizing the importance of cross-verifications between organizations and examinations of potential distortions. This created an empty space that soon buzzed with guesses and irritation. Stepping into the void was Avi Lobo, whose interviews in the media served as a focal point for demands of openness. He urged the prompt sharing of all images from Mars missions, pointing out that the subtle Perseverance transmission, though fascinating, required confirmation from the detailed orbital satellites. Lobo's list of verifiable oddities, featured in audio shows and broadcasts, pushed the organizations to respond. At the same time, activity surged on Discord platforms. Hobbyists in astronomy exchanged deep space network timetables and operational notes, attempting to piece together the incomplete view from any available fragments. The standstill in procedures transformed a standard information stream into a tense standoff, where each passing hour without updates heightened the enigma and the audience's aggravation. 7 specific irregularities now outline the puzzle of 3I/Atlas, each evaluated and examined by experts across the globe. The initial one involves its mass. Observations from the Center for Near-Earth Object Studies confirm a core so substantial that, despite releasing gases, its path alters by under 15 meters per day squared. This represents just a minor fluctuation relative to usual comet shifts. Next, pictures from Hubble depict a surrounding haze extending toward the Sun, contrary to expectations from solar wind dynamics. Rather than a trailing cloud of particles and vapors, the extension aims straight at the Sun, hinting at unusual dispersion or possibly deliberate propulsion. The Very Large Telescope's spectral analyses reveal prominent nickel spectral lines, whereas iron is almost undetectable. In comets from our solar system, iron and nickel typically coexist. Here, however, nickel prevails, a compositional marker evoking factory byproducts more than celestial remnants. Lab tests validate the proportion, but no established mechanism explains it. The fourth irregularity emerges from polarimetry data. At a 7 degrees phase angle, the polarization reading stands at -2.77%, with a reversal around 17 degrees, far beyond standard values for known comets. Various groups identify these as exceptional cases, challenging standard categorizations. Fifth, the path. 3I/Atlas traces an almost flat inclination, staying close to the ecliptic plane and setting up near passes by Venus, Mars, and, if forecasts prove accurate, Jupiter, all in one orbit around the Sun. Trajectories this flat are uncommon for objects from outside our system. Sixth, the schedule. Position predictions indicate the object's arrival coincides with a series of planetary alignments in quick order. The likelihood of this pattern happening randomly is low, implying the path was set well in advance of detection. Lastly, mapping the route shows it within 9 degrees of the 1977 WOW signal source, a connection that's indirect but sparks theories and inspires focused radio scans during the December period. Collectively, mass, haze, composition, polarization, path, schedule, and location. These peculiarities defy simple interpretations. The upcoming stage involves thorough assessments at perihelion and in the December rediscovery to assess whether this collection is mere chance or evidence of something extraordinary. October 29th marks the pivotal moment, perihelion, as 3I/Atlas reaches its nearest point to the Sun at 1:36 astronomical units. Over the following weeks, all irregularities and whispers focus on this event. Orbiters around Mars, quiet on public updates, are set to obtain their sharpest images while the object speeds up to about 68 kilometers per second. Yet the evaluation extends beyond one day. Starting November 2nd, the JUICE mission begins its specialized viewing phase. This offers a rare opportunity to observe the consequences from a distinctive position far out in space. For almost 3 weeks, JUICE's array of imagers and analyzers will probe for eruptions, breakups, or signs of artificial behavior. This effort, endorsed by the European Space Agency and monitored live by operators, is underway. As the sun's brightness diminishes, ground telescopes on Earth gear up for rediscovery in early December. Davide Finacci of JPL's Center for Near-Earth Object Studies describes this as the definitive judgment. Fresh measurements of position and movement are essential to validate or dismiss suggestions of unnatural speeding. December 19th serves as the ultimate milestone, with 3I/Atlas at its nearest to Earth, 188 astronomical units away. A worldwide array of facilities, antennas, and dedicated skywatchers stands ready to record the results. The timeline is locked in. Each milestone adds another level of verifiable proof, shifting the narrative from conjecture to concrete analysis. Reviewed studies from the search for extraterrestrial intelligence provide solid figures on the possibility of engineered transmissions to mimic a WOW-level radio signal from the distant reaches. At distances typical of the outer solar system, around 600 astronomical units, any transmitter would require at least a megawatt of output power, often significantly higher. This equates to the energy use of a modest town concentrated into a focused beam and directed accurately. For a frozen object wandering in the outer void, such demands push the limits of plausibility absent a clear, observable power source. No comet, asteroid, or familiar natural phenomenon approaches producing that level of targeted radio emission. Discussions of probability now revolve around evaluating the pile of irregularities involving 3 entities: mass characteristics, nickel composition, tail oriented toward the Sun, and orbital positioning. Experts from Basha begin with an extremely low initial assumption for an artificial source, under 1 in a million, before examining whether each fresh deviation operates independently. In that case, the probabilities alter sharply. Otherwise, the argument stays unconvincing. Leading SETI scientists advise restraint against stacking unlikely events without proven independence. 7 peculiarities in a single entity seem striking, yet if they're either fabricated or connected, the overall likelihood hardly improves. Currently, the sole reliable gauge of certainty rests at possible, yet unconvincing. Upcoming data releases will determine if this represents a random space oddity or a discovery that upends the probabilities completely. The tiny asteroid 2025 TF passed a mere 419 kilometers over Antarctica on October 2nd. Its size ranged from 1 to 3 meters across. Modest in astronomical terms, yet near enough to brush against catastrophe. The alert arrived belatedly. Fully 6.5 hours post its nearest pass, the Minor Planet Center verified its trajectory via orbital models, so imprecise they received a condition rating of 7 out of 9. Without warnings, without pursuit, it was merely a quiet, flashing intruder. Teams focused on planetary protection now assess the risks. How many others evade detection? On the Martian surface, the Perseverance rover's instruments have detected an intriguing yet encouraging anomaly. Within the Bright Angel and Sapphire Canyon areas, scientists identified organic compounds closely associated with vivianite, a blue iron phosphate that on Earth helps retain biological indicators. The rover's Sherlock and PXL tools charted these pattern distributions with high resolution. The close proximity of organic substances and minerals reactive to reduction offers the most compelling indication so far that primordial Mars might have supported or retained molecular evidence of life. An article in Nature Geoscience describes it as the top potential biosignature observed on the Crimson World to date. However, with NASA's budget trapped in partisan gridlock, even the mission to retrieve samples and confirm the findings faces potential elimination. In the meantime, solar activity stirs uneasily. Multiple coronal holes have released streams of solar wind exceeding 700 kilometers per second. Smaller coronal mass ejections accompany the swift currents, triggering geomagnetic disturbances at G-forces and displays of auroras reaching down to 40 degrees south latitude. Forecasters in space weather predict this could mark the concluding peak prior to the decline of solar cycle 25. A final outburst, yet potent enough to illuminate skies at middle latitudes and challenge the durability of global satellites. Inside a congressional chamber, a lone declassified clip activates the screen. A round craft recorded above Yemen withstands a Hellfire missile strike and continues onward. Authorities maintain quiet. Insiders claim reprisals for disclosing UAP encounters, while the Defense Department provides zero clarification. The conversation erupts across all media, merging doubt with intrigue. Overhead in the darkness, a trio of verdant comets vie for visibility. C/2025 S1, dubbed the Lemon Comet, intensifies to visibility without aid, with forecasts estimating magnitude 4 or possibly 3, an uncommon feat for recent comets. Post-perihelion observations benefit viewers in the south, as Swan remains dim but ascends in the northern pre-dawn. Their green tint stems from diatomic carbon and cyanogen fluorescing beneath solar UV rays. For a short period, backyard stargazers can catch all three, a grouping unseen since the dawn of the 2000s. At the same time, Starship's 11th test flight transforms prospects for recoverable launch vehicles. Booster B-15 executes a complex landing sequence flawlessly, as Upper Stage 38 endures an intentional removal of heat shield tiles and reignites its motors successfully. A mock Starlink cargo fulfills the objectives. This concludes the V2 phase. Subsequent flights will adopt the bulkier, sturdier V3 variant, enabling substantially larger orbital deliveries. China's Tianwen-2 mission is en route, aiming for Kemoalawa, a quasimoon object potentially a lunar remnant. Following sample gathering, the probe will proceed to 311P, a dynamic asteroid, in a decade-spanning effort merging moon studies with comet investigation. Still, these achievements occur amid growing organizational perils. With 15,000 NASA employees on furlough, just 3,000 staff sustain the ISS and Artemis programs. Suggested reductions risk axing a full cohort of research endeavors, raising alarms of talent exodus as experts eye international alternatives. The trajectory of American dominance in space now depends on political determination matched technical drive in equal measure. On October 3, 2025, the Perseverance spacecraft spotted a subtle blur exactly where 3I/Atlas was forecasted to be, right at its nearest pass by Mars, just 29 million kilometers distant. Even as more than 15,000 NASA employees sat idle on furlough, delaying the publication of detailed orbiter photos. Research groups recorded 7 significant irregularities, a haze loaded with carbon dioxide, nickel-present sans iron in the vapors, a beam of light stretching toward the sun, and an odd twist in polarization. Even with such discoveries, fundamental puzzles linger. Unavailable orbiter information, the precise reason behind 3I/Atlas's distinctive composition, and the essence of its size and motion all stand unresolved. Upcoming viewing periods via JUICE in November, plus Earth's signal recovery in December, promise additional insights. For the moment, though, just scattered bits of proof have surfaced publicly. The saga of 3I/Atlas continues to develop, influenced equally by rigorous research and logistical hurdles. Without fresh visuals and analyses, this entity endures as an extraordinary blend of interstellar wonder and bureaucratic reticence.